Oh, sorry, I didn't see you there. Let's just get rid of that. Alright, cool. We're looking at displaying data. We're looking at the frequency histogram here, which shows the number of goals scored by a football team in each game in a season. So let's jump into it. We've been looking at displaying data, and we're going to look at a few things today. We're going to look at histograms, and we're going to look at the cumulative frequency polygons that we can construct from that. They're also called ogives. Okay. So a few things with histograms. There has to be a half a gap width to start and no gaps between columns. That's really important when we construct this out, right? So let's have a look at this. We want the frequency histogram here shows the number of goals. I just read that. That's all right. Let's look at this question. Find the percentage of games where less than 7 goals were scored. So wording is very important here. We can see that this histogram has no gaps. It's got half a width thing here to start. And the percentage where less than 7 goals were scored, well, we want to know first of all, what's the total of this, right? So the number of games here, that's the frequency. So that's like how many total games there were, okay? And then this is what happened in each individual game, okay? So what I might do is I'll just write the number that happened here for each of these. So 3 happened here, 7 happened here, 5 were here, 1, this happened, 6 goals were scored once, this happened 0 times, and this happened 4 times by the looks of it. Cool. And so if we add these all up, we're going to get a total of 20 games. Okay. And then what's the percentage where less than 7 goals were scored? So less than 7, so that's all of these ones here. So that's going to be, so I'm adding up, just be careful, I'm adding up these numbers because that's how many times all of these happened, right? So 3 plus 7 plus 5 plus 1, that's going to be 16. So the percentage is for part A will be 16 out of 20, or that's just 8 over 10, or 80%. Okay. Awesome. Cool. Part B, find the mean number of goals scored by per game by this team. So the mean number, usually for the average, you add up everything and you divide by how many there are. Now here it's a bit less clear about, okay, well, what am I adding up here, right? Like I want to work out, first of all, okay, what does it mean to be adding up every score that's there? The thing you got to think about is, what does it mean when there were 3 goals scored in 3 games? Well, another way you could write that is you could write out, okay, give me the score for each game that was played, right? So if this happened 3 times, you could write it like this. You could do 3, 3, 3, and then separate them by commas, right? Here, the number of times 4 was scored was 7, so you could write the 4 out 7 times. So you're going to start to notice this is going to take a long time, so we don't do that. Instead, what we can do is I can say, well, basically what I'm doing is multiplying, right? This would be the same as 3 times 3. Adding these up, this would be the same as 4 times 7. So I'm going to do that for all of these individual ones. Now, what do I need to divide by? I need to divide by how many games were played, right? And how many games were played? Well, that's over here. There were 20 games. So let's go ahead and do that now. That would be 3 times 3 plus 4 times 7. And then I'm multiplying all these numbers together, right? So 5 times 5 plus 1 times 6 plus 0 times 7. I mean, that one's just going to be 0, but that's okay. I'll still write it. Plus 4 times 8. Okay, so let's calculate that all out. And so I get 100. And then I'm going to divide by how many there were. So there's 20 games, so divide by 5. And so that's just going to be, so the average is equal to 100 divided by 5, which is equal to 20. And that's how I can calculate go again. And then to calculate the average, I should do 100, so divided by 20, and that's going to be 5, which is the average number of games scored by this team. Now, just to make a note about this, remember the reason why we need this half gap thing is because if I wanted to construct a frequency polygon, what I would do is I would mark the centers of each of these columns, and then I would connect them up using a straight line. So if I connected this up like so, then that would be my frequency polygon, and the idea is that the area underneath that shape, the polygon, which just means shape, is going to be equal to the area of the column. So you could do that pretty easily as well. But the next thing I'm going to look at is slightly different. It's not a frequency polygon, it's a cumulative frequency polygon. And we looked at that when we looked at Pareto charts, right? So what you want to do for this one is you also want to think about, okay, a cumulative thing, that means it's a running total, right? It's a running total. And so if it's a running total, the graph is going to look a bit different. It's going to look similar to that shape that we drew in the Pareto chart. Difference with this one and these ones up here is this one we were connecting the centers of all the columns, but for the ogive, this particular line graph, which is cumulative, we call it an ogive, or ogive, or ogive, I don't know, creative explanations there, pronunciations, corner to corner, starting from the bottom left of the first column. So what that means is I'm going to be doing something. I'm not going to start at the corner of the graph anymore. I'm actually going to start from here, go to this corner, go to this corner, go to this corner, and then to the top. Okay, so that's something that's slightly different from this one, just something to keep in mind. All right, let's look at this question. So we've got a new shopping center, which is open near a primary school, and we're just doing a survey. I remember doing this in primary school actually. And it wasn't it wasn't a shopping center, but we just went out to like a road and we just like watched the cars go by, and it was pretty fun experiment to gather some information. And we looked at, in this case, we're looking at the number of motor vehicles that pass the school each afternoon between these times here. Okay, and we've put it into this table, which has a few interesting headings. So we've got the class center, frequency, cumulative frequency, and this score here, you notice it's a range, right? It's a range because at the moment they're just grouping 100 to 124. They're grouping 125 to 149. And then when you look at this, the cumulative frequency, it's different to this other one because this one here was separated by the individual scores and it showed each of the individual frequencies, right? But this one over here doesn't show that. It's a cumulative frequency. It's a running total. So 60 is not represented by this one over here. It's actually represented by the whole thing. That's the whole amount. So that's something to keep in mind. So 60 is the whole amount, right? And the other thing is we need to fill in these class centers. So the class center is basically a measure that is representative of this, we call these clusters, like these groups here. And the class center is the average of the two outside values. So you can do that by just doing like 100 plus 124 and then dividing by 2, right? So it's giving you 112. But you can also just kind of work that out in your head as well if you prefer. When it gets to these values here, it becomes a little tricky to work out what's exactly halfway, so I'm going to do that method. So 149, and make sure you divide by 2 afterwards, because otherwise you're going to, the calculator is not very good with doing things out of order, because if you do it like this, you're going to get not the right value, so just do it after you've done that calculation, something to keep in mind. 175 plus 199. 2, 187, okay? And that's where these values here at the bottom come from. Yep. Now, after you've done that, we want to find the class centers. We did that. And then find the value of x in the table. So to find the value of x here, you notice how it's the frequency of the individual one here, right? And then you might be inclined to think, oh, 137, I go here. And it looks like it's about 25, which is the same as this number. So that should be the frequency. But that's the trap, right? Because remember, that's the cumulative frequency. It's the running total. How do you find like the individual frequency? If you remember back from the Pareto chart, the way we did it was basically, because it's a running total, you're adding these on each time. So if I have 25 here, and then, ooh, I don't want that. Can I fix that? There we go. If I want 25 here, and then the next one cluster gives me 20, I'm adding that on to give me 45, right? And then same thing, I add on 15 to get to 60. So, I mean, how do I work out what the individual one is for x? It's basically what's the difference between these two values. How do I get from 10 to 25? I have to add on 15, right? So x is 15 in this case, yeah. So that's the class centers and the value of x in the table. Remember, it's a running total. It's a cumulative frequency. Next bit here, how do we find and construct this ogive? So remember, it goes from the corner to corner now. We're not doing just the normal frequency polygon, it's a cumulative one. So the idea is that it needs to end up at 100%. And this is the way we're going to construct them. we're going to construct the lines that come out like so, just like that. Okay, and that's going to be my frequency polygon, cumulative frequency polygon for this data set. It's meant to be representative of the running total. We have to connect them from corner to corner of these histograms. Hope that helps.